In August 2017, Indonesia Ministry of Public Works for the first time applied polymer modified asphalt for about 700 meters at Udayana University, Indonesia. In the final job mix design, that mixture makes stability improvement around 40% and has calculated can reuse 2.5 ton kilometer plastic wash. Although in material engineering scope it will form plastic agglomeration which will improve pavement stability but accelerates road deterioration because this material have opposite chemical compound. Asphalt is polar and the polymer is non-polar. Need another material for supporting this compatibility that we call the coupling agent, so plastic wash optimally can be used because approximately 10% of plastic pollution in the world was produced from Indonesian consumption, and the higher percentage from this diagram is LDPE or low density polyethylene that also really potential for polymer substitution material. Of course, with lignin with coupling agent admixture. There is some previous research about coupling agent material, and one of them that more potential and more advantage is the coupling agent of lignin. Furthermore, lignin is a byproduct of the pulp and paper industry that just a small percentage that has been used, approximately just 2%. And from this research background, we collaborate to develop polymer modified asphalt research about stability improvement of asphalt concrete binder cost using LDPE plastic wash with lignin as coupling agent by our team, myself Thoriqul Huda from ITS Civil Infrastructure Engineering, Mofili Firdausi from ITS Civil Infrastructure Engineering, and Muhammad Rizal Afif from ITS Material Engineering. There are three main topics from this research following this part. Initially, we determined the percentage of asphalt content following Bina Marga specification. From this calculation, we determining 5 number of asphalt content. And then we determining the percentage of polymer from previous research by Muqaddam 2018 using 4 number of plastic content. The result of this part is optimum proportion of asphalt and LDPE content. After that, we prepare coupling agent lignin from previous research by Su 2015 using 4 number of lignin content, and we mix together to be polymer modified asphalt or PMA. Particularly for PMA, we did physical analysis to indicating mixture morphology by SEM or scanning electron microscopy and chemical bonding by FTIR or Fourier transfer infrared. Moreover, with addition of aggregate for the SCBC specification, we was formed and compact them to be SCBC specimen and did mechanical analysis. For SCBC specimen, we use Marsa stability test refer to diagram of stability parameter and flow parameter that was mean plastic deformation of specimen. From those parameter, we can decide another Marshall stability test parameter under Bina Marga specification license. This chart shows us about film parameter for each specimen. Nearly all of specimen increase film parameter following an addition of LDPE content. About this condition, we assume that over the time later, plastic agglomeration will downstream to the bottom layer of surface pavement that affect to porous condition in the top layer due to lack of asphalt that will increase the risk of pavement damage. These charts tell us about the stability parameter. Almost all of the specimen has improved stability following the addition of LDPE. About this condition, we recapitulate of Marshall test without lignin addition, and we get recommendation proportion is 5.65% of asphalt plus 6% of LDPE that we will add with lignin coupling agent. In addition, coupling agent analysis, we try to compare mechanical analysis by Marshall test with physical analysis. This graphic tells us about FT air test result that indicated hydrolysis reaction. Moreover, there are carbon and oxygen bond stretching that indicated weak bond or van der Waals bond. And from morphology test by SAM, we can say that the addition of LDPE will form plastic agglomeration in number B. And addition of lignin coupling agent in number C will reduce the plastic agglomeration. And from Marshall test stability result, this chart tells us about stability parameter chart. There are uptrend stability until 1% of lignin addition, and there are downstream stability on lignin content more than 1%. And for film parameter chart, an optimal point on 1% lignin addition. And this is recapitulation of Marshall test with lignin addition. There are two variables that not recommended under Bina Marga specification license. And final optimum proportion, we get 5.65% of asphalt weight per aggregate plus 6% of LDPE weight per asphalt and plus 1% of lignin weight per asphalt. And this is result comparison from our research that we can improve stability parameter up to 90% using lignin coupling agent, and by previous research that just can improve stability parameter for about 30%. And in Ministry of Public Work research result that can improve for about 30% of stability parameter, but they apply in ICBC layer. And this is the conclusion of our research, that the first lignin addition effect to LDPE and asphalt be more compatible. The second, lignin addition improves stability parameter up to 89.5%, and the determined optimum proportion from ICBC pavement is 5.65% asphalt and 6% LDPE plus 1% lignin. Thank you very much for your attention.